I want to think about that and try it out and see what I think. Looks like I've printed this out a bunch of times. Okay, I certainly have. Yeah. All right. Okay, so this is going to be our review of flip-flops and our introduction to sequential circuits. And I put a couple problems on here that I had used in the past that looked very similar to what you have in your homework, but not identical. So should give you some ideas for the homework that is, it's due at midnight, right? Or yeah, okay, so you still have time. All right, so let's talk about what this first flip-flop is. So what is this first flip-flop? And yeah, so it's a D flip-flop, and it's a positive edge D flip-flop.
So because of the no bubble.
Because of the no bubble. And our characteristic table will give us what the next value of Q is, which often depends on the previous value of Q, but for a D flip-flop it does not, but I'll go ahead and put all the different values, possibilities in. Characteristic table is just like a truth table, just has a different name for a flip-flop. And as long as you're at the positive edge, so it changes only on the positive edge of the clock. So it only changes once every clock cycle. And when you get to the positive edge of the clock, it'll look at the value of D, and whatever D is, that's what the next value of Q is. So here it'd be 0, 0, and here it'd be 1, 1. And for those of you who are just coming in, if y'all would... All right, so the only difference between the D flip-flop without the bubble and the D flip-flop with the bubble is that this one is a D flip-flop and it's negative edge triggered. And it changes only on the negative edge of the clock. So Q only changes once per clock cycle. And for the D flip-flop, we like to say Q follows D. So Q is going to become whatever D is. So at the change of the clock, whatever the D input is, that's what the Q input is going to be. Or the Q output. The T flip-flop is a little trickier because the T flip-flop definitely has memory because it depends on the previous value of Q. So it depends on the value coming into T. It also depends on what the previous value of Q was. So I'm putting this little star to stand for the next value of Q, and Q is the previous value of Q. And this one is positive edge triggered because there's no bubble. So it changes on the positive edge of the clock and only changes once per clock cycle. And we have our 4 possibilities. And if T is 0, there's no change. This is where people get messed up because you think T is 0, well, Q is 0, but that's not true. T is 0 means there's no change. So if Q was 1 before, it's still 1. And if T is 1, it toggles. So toggle is the word that means becomes its complement. It flip-flops. So when T is 1, Q becomes the complement of what it was before. So when T equals 0, Q stays the same. And when T equals 1, Q toggles or flip-flops to the other value.
For the D flip-flop, the negative one,
Uh-huh.
the only thing the negative means is where it like changes. It doesn't change any of the values. It's the same truth table.
Same truth table, yep. Okay, so the JK, and I always look this up before I start this because I mess it up if I don't. I can never remember. I think J is like S. J is J, K are both 0, then no change. When J is 1, so K is 1. K is the reset. J is the set. But I've seen ones that have web pages that have that wrong. So let me check here. That's the same place I just was. J is 1, K is 0, J is the set, J is 0, K is 1, that's the reset. Okay. It's just for me to not forget between now and the time I write it. Okay, so we have 3 variables to look at. We have J and K and Q, and then we have to see what the next value of Q is. So we'll have 8 possibilities here. This is very similar to the SR latch, except with the SR latch, you try to avoid S and R from both being 1, but with the JK flip-flop, it is fine for them both to be 1. Okay, so the first thing that happens is if J is 0 and K is 0, so if J equals K equals 0, we have no change. So whatever Q was before, it's just going to stay where it is. So no change. If J is 0 and K is 1, that's a reset, meaning the next value of Q will be 0. J equals 0 and K equals 1, Q next will equal 0. And if J is 1 and K is 0, then Q next will be 1, and that is a set. So when J is 1 and K is 0, the next value of Q will be 1. And if J equals K equals 1, that's a toggle, and the next value of Q will be the opposite of what it was before.
What is that again? Q.
Uh,
This is J equals 0 and K equals 1.
Q next equals 1. Next value of Q equals 1. So we're going to plot the Q output of a positive edge triggered T flip-flop given the inputs below, and we'll assume that Q is initially 1. So what I like to do is, since it's positive edge triggered, I know it can only change on the positive edge of the clock. So I draw little vertical lines at the positive edge of the clock, and I know that's the only place Q can change. And we assume, I don't know why I put 1 at the bottom, it's be weird. And we're starting with Q equals 1. So when we get to the positive edge of the clock, the flip-flop looks at what the signal T is, and it sees that T is 0. And when T is 0 on a T flip-flop, when T is 0, Q stays the same. When T is 0, Q stays the same. And so when we got to the positive edge, T was 0, so Q stays the same. When we get to the next positive edge, we look at the value of T here, and here it's 1. And in a T flip-flop, when T is 1, it toggles. So now it'll become 0. And then when we get to the next positive edge of the clock, we look at the value of T, see that it's 0. 0 means no change. So we stay at 0. And then when we get to the next positive edge of the clock, we see that T is 1, which means it toggles, so it'll go up to 1. So it only changes once every clock cycle.
Why did it start 1?
That has to be given, and so it said assume Q is initially 1. So that information has to be provided. If it's not provided, like let's say this was a test question, it's not provided, I would assume 0, but I would write assume Q starts at 0. But it should be given, but just in case someone forgets. Okay, so here we have 3 different flip-flops or latches. We have a latch, which is the top one, and we have a positive edge flip-flop, and we have a negative edge flip-flop. So we're going to have the signals for QA, QB, and QC. And I'm not going to draw QA bar, QB bar, and QC bar because they would just be the opposite. And it says to assume that each of these is initially 0. So we'll assume they all start at 0. Now, QA is a latch, and what that means is it has a clock, but as long as the clock is high, it can change. So it doesn't just change at the edge. It can change as long as the clock is 1. When the clock is 0, it can't change. And so we have that the clock is 1 here, 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 and here. So for the latch, it can change as long as it's in that region. So it starts at 0, and then it gets to where the clock is positive, and then it just follows D. It's going to do whatever D does, a little bit behind schedule because it does take some time to propagate. So it's a little bit behind schedule. But then once it gets to the negative edge, it can't change at all during the negative edge. And then when it gets to the positive edge, it just copies the signal D. And then in the negative edge, it doesn't change. And then in the positive edge. And so it'll still be high during this part right here because it couldn't change during the low part, and it'll continue to be high there. So the next one is a flip-flop, and that's different because a flip-flop only changes once each clock cycle, if it changes at all. So it's going to start at 0. These are all D's, so it'll do whatever D does. So when it gets to the positive edge, it looks, the signal D is 1, so it becomes 1, and it stays that way until the next positive edge. And then when it gets to the next positive edge, it sees that D is 0, so it goes down to 0 and stays there. And then at the next positive edge, it's still 0, so it stays 0. And at the last positive edge, D is 1, so it becomes 1. And then our negative edge flip-flop is going to change only on the negative edges, which are here. It starts at 0. When it gets to the first negative edge, it's 0, so it'll stay 0. When it gets to the next negative edge, it's 0, so it stays 0. When it gets to the next negative edge, it looks like it's 1, so it'll become 1. And at the last negative edge, it's still 1, so it'll stay 1. The first part of this worksheet I've done a gazillion times, so I'm used to it. What's coming up, I wrote it a couple years ago, and I shouldn't admit that I did not have time to practice it, so hopefully I'll remember everything. I've done Digital Logic 2 a bunch of times, but I wanted to make sure I didn't use the actual problems that you had on your homework. So complete the timing diagram for the circuit below with positive edge triggered flip-flops. Assume Q1 and Q0 are both initially 0. All right, so let's see what we've got here. All right. All right, so these are both positive edge flip-flops. So they can only change at the positive edge. I don't know why I have the negative edge drawn in there. I just copied this from somewhere. So We can only change at the positive edge. I'll draw these positive edges down. Oh, but you do have to be careful because sometimes these problems are sneaky. The clock, check and make sure the clock is really the clock, because the input into the clock doesn't have to be the clock. It could be something else, and we'll see that in a minute. So it changes whenever the positive, whenever the input, so a positive edge flip-flop changes whenever input into the clock goes from 0 to 1. So that doesn't necessarily have to be the clock. So it just means whenever that input goes from 0 to 1, it's going to change. In this particular one that I have, the clock is the clock, so that would be it. And so I have Q1 is our first one, and Q0 is our second one. And then, did I cleverly call these like, well, I do have Q1 and Q0, but not in the right order. Okay, so, no, in the right order. Okay, so Q1 is on top. Okay, so when we get to the first positive edge, right here, Z, our input is 0. This is a D flip-flop, and so Q1 will become 0 because it follows, well, it already was 0, but it'll stay 0. Okay, now, this second flip-flop, Q1 was 0, and so its input into this is 0, and so when we so Q0 at this first positive edge remains 0. Oh, is this the one that I'm remembering that I made something that just stays 0 the whole time? Let's see, I might have done that. Okay, when we get to the next positive edge, yep, when we get to the next positive edge, Z is 0, so Q1 doesn't change. And since Q1 didn't change, Q0 doesn't change. But when I get to the next positive edge, Z is 1, so Q1 becomes 1. But it has not become 1 at the time the clock changes. When the clock changes, what's sitting out here on Q0 is still 0. And so Q0 doesn't change yet. On the next positive edge, Q1 goes back down to 0, but Q0 goes up to 1. And so there's a delay. Each flip-flop is going to be like a clock cycle behind. When you have D flip-flops in sequence like that, the signal is going to travel from flip-flop to flip-flop.
It's on the page before this one. You said there's a delay.
A little bit of a delay.
And it also it jumps down before it leaves the positive as well. One of them. So just.
Oh, you mean why I delayed it a little bit?
So there's a delay.
Just because it takes a little bit of time. I don't think Dr. Manal is gonna. I don't think she really is gonna test the delays. I don't remember that she does. Okay. All right. So let's take a look at this one. And notice that Q bar is the input into D for our first flip-flop. And so it's a positive edged flip-flop, assuming they all start in the low state. So if it started in the low state, what is Q bar? Like if Q is 0, what is Q bar when we start? It's going to be 1. And Q bar is the input into the D. So we get to the first positive edge, it's going to become 1. So Q becomes 1, and then what does Q bar become? 0. And let's just stick with Q0. And we can see that because wait, what? Oh, because we're using Q bar. That's why. Okay, it's like, why is it oscillating? Okay, so now when hold on, let me get this right. I did not do this right. It's only going to change on the positive edges. So it was, when it got to the positive edge, it became 1. Once it became 1, when it got to the next positive edge, it became 0. And when it came to the next positive edge, it became 1. And when it got to the next positive edge, it became 0. And then 1 and 0 and 1 and 0, because each time we're getting Q bar, so it will oscillate. Make sure I have that right. Yes. Okay, so now let's look at Q1. Its input is Q0. So at the first positive edge, it's going to be 0 because Q0 hasn't had a chance to change yet. At the next positive edge, it's going to be 1. And then at the next positive edge, it's going to be 0. And then 1, and then 0, and then 1. It's always going to be 1 behind Q0 because it's not going to change immediately when Q changes because there's a time delay. So Q2, when it gets to the first positive edge, it's going to be 0. And when it gets to the second positive edge, it's still going to be 0 because it's looking back at Q1. And Q1 hasn't had a time to change yet. And then after that, it'll start its oscillations. So what do you think will happen with Q3? Yep. Okay. The circuit below is a 3-bit up counter with T flip-flops. Assume that Q2, Q1, Q0 equals 0, 0, 0 initially. For flip-flops 0 and 1, explain what happens and why it happens at 3 points. Q0, the clock input to flip-flop 1. So 3 points, Q0, the clock input to flip-flop 1 and Q1 at each of 3 time instances. The first active edge of clock, the second active edge of clock, and the third active edge of clock. Okay, so we're looking at Q0, and I'll say first active edge, second active edge, and third active edge. Okay, what is our input into our flip-flop? Just 1. What does a T flip-flop do with an input of 1? It's going to toggle. So initially, it was 0. Now, Q0 is the output of this T flip-flop. So at the first active edge, it's going to toggle. It'll become 1. At the second active edge, since the input is still 1, the input is always 1, it'll toggle. And at the third active edge, it'll toggle. So that's telling us what's happening at Q0. Now let's look at the clock input to flip-flop 1. Well, to answer that, I want to look at what Q bar is doing. So Q bar is initially 1. So at the first active edge, it's changing to 0. Because it is changing to be the opposite of what Q0 is. At the second active edge, it's changing to 1. So what that means is for Q1, so Q1 experiences a positive clock edge only at the second clock edge, because the input at positive quotes clock edge only at the second clock edge, because its input is not the clock, its input is Q bar. And so Q1 is initially 0. At the first active edge of the real clock, its clock edge is changing to 0. So that means it's not going to do anything. So it's going to stay 0. At the second active edge of the clock, it's changing to 1. That's a positive clock edge, so it'll toggle and it'll become 1. Why don't y'all try to figure out when will Q2 change? So here's my question for you. When will Q2 change? So what is the input into the clock for Q2? Q1 bar. Q1 bar. So if we made a table, so initial, first clock edge, second clock edge, third clock edge, fourth, fifth. So Q1 we said was 0, 0, 1 at the second clock edge. And I've made my work too messy. Let's see. Definitely made my work too messy. Let me. Always done this with a timing diagram before. I don't know why I didn't think I wanted to do one this time. Okay, so the Q0 bar would be the opposite of this. And then Q1. So Q0 bar is the input into the clock for Q1. And so it can only change on the positive clock edge, so only when Q0 bar is going from low to high. So it can change here, and here, and here. And let's see how it changes. It's a T flip-flop. Is its input 1? Yes. So if it's going to change, it'll toggle. So it'll be 0, and then 1, and then 0, and then 1. And then Q1 bar will be the opposite of this. And that is the input into the clock for Q2. And so it can only change on the positive edge of Q1 bar. So it can only change here. So it'll be 0 until it gets to here. So Q2 does not change until the 1, 2, there's the first, second, third positive edge of the clock. Okay. All right. So let's take a look at this one here. From the circuit below, what is the reading of output values on consecutive clock pulses starting from Q2, Q1, Q0 equaling 0, 0, 0 until reaching 0, 0, 0 again? All right, so let me write them. No, it has them in this order, 0, 1, 2. Okay, what's going to happen with flip-flop 0? Change to 1. And is it going to do that every time? Is it going to toggle every time? Every time there's a new clock cycle? Yeah, because its input is 1. Its input is 1, so every time it's going to toggle. What about flip-flop 1? No, it's because it actually has just the regular clock. So it's going to be the same, yeah. When is flip-flop 2 going to change? Well, it's always saying a 1, but it also has to be at a positive edge. So it has to be when Q1 is going from 0 to 1. So it's going from 0 to 1 here, so it'll change. So it's not going to, no, but it doesn't, it's, no change. 0 to 1, so it'll change. 1 to 0, no change. Y'all see how that worked? And I think I did this one for a different professor. I don't think y'all need to worry about this one. So you can skip 8. Yeah. Y'all can skip 8. I did that. There are several professors who teach this, and this would be something that he would have wanted, but I don't. Y'all do know what exclusive OR is? Yeah, okay. That's what you need to know. You don't need to know. Excellent. All right, thank you so much for coming. Can I answer any questions for you before you go?
This will be posted tonight?
This will be posted tonight. I actually have time to